Hi everyone. Today we are going to discuss partial differentiation part number 3rd. In this part we have to discuss concept and example of composite function. So you know very well what is a composite function. What is a composite function? So let's see. If u is a function of here, suppose r is there, u is a function of r and r is a function of here two or more variable, means for example suppose r is a function of xy, then we say that u is a composite function of r. U is a composite function of r, means simply r means what is that is x and y. So it means the definition of composite function is there. Now let me start in deeply what is actually concept of composite function. So let's see. First I am writing here what is a composite function. The composite function means here, suppose for example I am taking the first definition is there, or we have to take the technical definition of composite function. That's very easy to understanding. So for example, let u is a function of here, I am writing now in this way, u is a function of r and r is again function of two variable and r is again function of here x and y. Means I am taking here the next function, suppose f1 of r and that is f2 of x comma y. That is first function and second function. Then what I mean to say, then u becomes composite function of x and y. So that is in array we have to show if u is a function of r and r is a function of x comma y, then u is a composite function of x and y. So in this case, how we find the partial derivative of u? Now u becomes function of two variable, guys. U becomes function of two variable, means what is that here, function of two variable x and y. So therefore if we are to calculating dA by u by dA by x, if we are to calculating dA by u by dA by x, so how it will calculate? First we have to differentiate u with respect to r, that is u is a function of r first, and then r is a function of here x plus or we want to also write now is in this way, dA by u by dA by x is nothing but first we have to differentiate u with respect to r and r with respect to x, that is simply dA by u divided by dA by x. Also if you have to write dA by u by dA by y, so how it will be find out here? So first u is a function of first what is that r, and r is again function of here y, so that's why r differentiation with respect to y. So these are the simple result for r is a function of two variables, right? Number second, if you have to consider here again, now let u is a function of now f of r, right? And r is a function of two or more variable, guys. Means I am taking the r is a function of here x comma y comma z. Then u becomes what is that? This is a composite function of what is that here, x, y and z, that is x comma y and z. So that is in array, if you have to say u is a function of r and r is a function of x comma y comma z, then u is a composite function of all these x, y, z. Then you have to calculate how to calculate this dA by u by dA by x. Now this is very easy. DA by u by dA by x is what is that here, dA by u divided by here dA by r first, and then dA by r divided by dA by x first. Also if you have to calculate dA by u divided by dA by y, so this can be done by dA by u divided by dA by r first and dA by r divided by dA by y. Also, if you have to calculate dA by u divided by dA by z, so you have to just calculate now in this way. First, u is a function of r, and then r is a function of z is there. So in this way you have to calculate this result. So actually we have to also see by using this array diagram. So what is, or graphically I am saying that how to show the composite function graphically. So graphically we want to also show. So let's see. Let's suppose u is a function of f of r is there. So here u is a function of here f of r, right? And this r is a function of here, what is that, x and y. So let's see, suppose r is there, r is a function is there, right? So simply u is a function of here clearly r. So I'm showing by using the diagram is here. So let's see, u is a function of r is there first, and r is a function of x and y. So let's see, I'm drawing the very correctly is here. U is a function of r, right? And r is a function of here x and y. So where is x and y? So suppose this is x and this is y, right? This is x and this is y. Now see, first u is a function of r. I am showing the arrow diagram is there. R is a function of x and y. I am showing by also array diagram is there. And then u becomes the composite function of x and u becomes the composite function of y. Means what do you mean to say here? What I am saying here, u is a composite function. That is what I am saying here, composite function of y. Also here composite function of x is there. I hope so you have to understand this. Now for second, what is that? For second, u is a function of r first. U is a function of r first. So r is there, and r is a function of here x, then function of here y, then function of here z. So I hope you are to understanding this. U is a function of r is a function of x, y and z. Then what is that? U is a composite function of here x also, u is a composite function of here y also, and u is a composite function of here z also. So therefore u is a composite function of here x comma y comma z is there. So this is all about composite function. I hope you are to understanding this. So how it will be calculated? So dA by u by dA by x, it can be calculated by dA by u by dA by r first, then dA by r divided by dA by x. Means you want to find suppose dA by u by dA by x, then you how to do is here dA by u by dA by r first, and then dA by r by dA by x. And in this way we have to understood the composite function. I hope you have to understand this. Now let me start example on composite function. So let's see. If u is f of r, means u is a function of r, and r is a function of, that is r, we have to actually define here, r is x square plus y square. Prove that dA by square u upon dA by x square plus dA by square u upon dA by y square is equal to, that is f double dash of r plus 1 upon r f dash of r. Or another notation is there. What is that? dA by 2u by dA by x square means here derivative of u with respect to x 2 times, means u x x, plus here similarly u y y, that is equal to, this is nothing but f double dash of r means here it is a derivative of u square, means dA by 2u upon here dA by r square, means dr square. So this is nothing but here guys ordinary derivative of r, so that's why I am taking here the du, means d square u is there, right? So d square u upon dr square plus, instead of this 1 upon r f dash of r, so this is only du divided by dr. This is only du divided by dr. I hope you have to understand this. Now let me start the solution. So let's see how to solve this. So solution, let's see. Here you observe u is a function of, so I am writing here very clearly. Here u is a function of, here what is that, r. R is a function of here x comma y. That is u becomes composite function of x and y. Composite function of x and y, right? So therefore we have, if this is a composite function u, we have, so how to find dA by u by dA by x? So there is a formula. This is what, dA by u divided by dA by r, and then dA by r divided by here dA by x, and dA by u divided by dA by y. How it will be calculated? It is first dA by u divided by dA by r, means u is a function of r, and then r is a function of y is there. So in this way you have to calculate it. That is step number 1 you have to do here, right? Now after that, you know also very well what is r. So r is given to you. Let r is equal to, that is under root x square plus y square, right? So r square equal to square root is ignoring now here, taking square on both sides. So what is that here? X square plus y square. So you have to just taking differentiate with respect to x, guys. Differentiate with respect to x and differentiate with respect to y. So therefore it is clearly you have to understand here what is a dA by r divided by dA by x. So you know very well that is x divided by r, and dA by r divided by dA by y. Because of that, r is a function of two variable x and y, therefore derivative of r with respect to x and y we have to happening is there. So dA by r by dA by y, it is becomes y divided by r is there. I hope so you have to understand this. Now u is a function of r, and dA by u by dA by r, or dA by f divided by dA by r, or f dash of r, all same meaning for that. So therefore we have to getting dA by u divided by dA by x. Now in this way, this is what, that is a dA by u divided by dA by r into dA by r upon dA by x. But you know that very well, dA by u by dA by x into dA by r by dA by x, the value is becomes, that is x upon r, right? X upon r. So for that we have to see, this is called as, this is f dash of r. This is f dash of r into x upon r. For consideration we have to take an equation number 1, right? So also we have to just it differentiate. So very carefully I am writing here, dA by u divided by dA by x, that is equal to, that is a f dash of r into x upon r. We have to getting this first. Now carefully note that the second order partial derivative, it can be written as, now we have to differentiate, just differentiate this equation with respect to x partially. So what will get the next step? So you have to getting the next step as dA by 2u upon dA by x square, that is equal to, here f dash of r in bracket, what is that here, r of 1, means r into derivative of x is 1, minus x into here dA by r by dA by x upon totally here becomes r square. That is, we have to use the product rule is here, plus x upon r f double dash of r, and dA by r divided by here dA by x, dA by r divided by dA by x. So this is a dA by 2u upon dA by x square, right? So we have to just simplifying this. So therefore this is equal to, this is f dash of r in bracket, what is that in bracket, so r minus x into dA by r by dA by x, it will get x divided by r is there, right? Divided by total. So just wait, I have to write now in this way. Total divided by here r square, and bracket is complete here, plus x upon r, means here dA bar by dA by x is again x upon r, so it will get x square upon r square into f double dash of r, right? F double dash of r. I hope so you have to understand this. So that is equal to, also you have to write f dash of r, also simplifying this. So what we will get in the last steps, so that is r square minus here x square divided by here, what is that here, r square and denominator r, so it will take r cube in plus here x square upon r square, at that time f double dash of r is there. So this is what, this is a dA bar 2u divided by dA bar x square. So now I am writing similarly, what is that, I am writing directly dA bar 2u upon dA bar y square, and it will take the value, what take the values, that is f dash of r. Now here dA bar 2u upon dA bar y square, similarly I am taking here. So this is what, replace x as y, so r square minus here y square divided by here r cube, right, plus y square divided by r square, and f double dash of r is there. So this is equation number 2 and this is equation number 3 for consideration, and therefore LHS equal to, LHS means in your equation given that, what is LHS, dA bar 2u upon dA bar x square plus dA bar 2u upon dA bar y square. So let's see. So LHS becomes here dA bar 2u upon dA bar x square plus dA bar 2u upon dA bar y square. We have to just putting the values is here. So after the putting the values, it will becomes dA bar 2u upon dA bar x square, means what is that here, f dash of r, right, in bracket r square minus x square divided by r cube plus x square upon r square f double dash of r plus dA bar 2u upon dA bar y square, this is again f dash of r in bracket r square minus y square divided by r cube, bracket complete, plus y square upon r square f double dash of r. So you have to just take the common terms from there, after simplification you will have to get here f dash of r upon r cube, right, f dash of r upon r cube. Now common term is what is that here, so just simplifying, it will take 2r square, so I am taking now inside the bracket, that is a 2r square minus x square plus y square. Now this is common term I am taking here. Now this bracket here complete, plus in the next term what we'll have to getting here f double dash of r upon what is the denominator, that is r square, and into again is here, what is that, r square is remaining, r square, it is nothing but that is x square plus y square. So I am writing now here very clearly, that is x square plus y square, that is x square plus y square. So right, so therefore this will take the f dash of r divided by r cube inside the bracket 2r square minus, you know, r is what is that, r is x square plus y square. So instead of this x square plus y square, we have to write minus r square plus f double dash of r upon what is that, r square, and again x square plus y square is equal to what is that, r square. So since I am writing the reason is here, r square is equal to x square plus y square, right? So therefore what you will get here, therefore you will getting the next step, that is your answer, I hope so, that is f double dash of r, right, r square get cancel, plus 1 upon r is the remaining, and into f dash of r. So this is what, this is LHS, and equal to, you check the RHS is the same or not, you check RHS is f double dash of r plus 1 upon r into f dash of r. So this is RHS. I hope so you have to understand this, LHS equal to RHS, hence the proof. Understood this? In this session, we discuss what is the concept of composite function and how to solve the example by using composite function. I hope so you have to understand this very well. Thank you.